Alrighty guys, so today we are going to be going over the instructions for the calorimetry lab. Now before we start, let's talk about the purpose of this lab. So the purpose of this lab is to calculate the specific heat of different metals to determine their identity. Okay, so as you can see in front of you on the screen, there are 5 different metals that you'll be working with, and what you'll be doing is you will be finding their specific heats using the calorimetry calculations that we talked about. And by comparing it to the table that's on your pre-lab paper, you will be able to determine what the identity of all 5 of these metals are. Alright guys, so let's go over the important safety rules for this lab. Now first of all, as you can see, there is boiling water, and so the surface of that hot plate is extremely hot. So just make sure that you exercise caution when you're working around the lab station where this hot plate is. I want to make sure that you guys don't get burned and that hot objects don't fall off. Second thing is that you have to use these tongs that are at your lab stations to move the metals. So what you're going to do is you're just going to grab this small bump at the top of each metal, and this is how you are going to transport them around. Do not grab the metals like this. It is very unstable, as you can see. So you're going to be grabbing that top bump in order to move it. So just make sure you're using tongs to move the metals around. Next, make sure that you do not move the glassware and hot plates on the lab surfaces. So at your lab station, you will see these hot plates and you'll see glassware on it. Do not move them from your lab station. Don't adjust the position. They should be in a good position for you. The only thing you should be doing is adjusting this dial in order to control the heat and unplugging them at the very end. And then last but not least, when you're done with the lab, make sure you unplug the hot plate and make sure that the cord, the power cord, is not touching the top of the hot plate. Okay, you don't want the power cord to melt. Okay, so that's going to be the lab safety rules. So let's just go over them one more time. Make sure that you're careful around hot objects in the lab. Make sure that you guys use tongs in order to move the metals. Make sure you only move the metals by grabbing that top bump. Do not move the glassware or the hot plates at your lab station. And make sure that you unplug your hot plate after you're done, and do not put the cords on the hot surface. Alright, so right now we're going to talk about how to make your coffee cup calorimeter. So we have a sample right here. As you can see, it's made out of 3 coffee cups. So for your calorimeter, you are going to obtain 3 coffee cups. Okay, now 2 of them are going to make up the bottom where you put your water for your calorimeter. But this top part right here is going to be your lid. Now, to make the lid, we have to cut a part of the coffee cup off. So let's get the 1 cup that we're going to use for the lid. And what you're going to do is you're going to make a small cut just up to this first line right here. Alright, so you're going to grab a pair of scissors and you're just going to make 2 cuts like that, just where that first line is going to be, just like that. So you're going to make 2 cuts on the coffee cup so that you have something that looks like that. Next, you're going to get your scissors and you're just going to cut horizontally across the first line that you cut up to. Alright, so if you cut the piece off your calorimeter, you should get something that looks like this. And then lastly, you're just going to get scissors and cut off just this top part of the coffee cup. Alright, so once you cut that piece off, you should have something that looks like this, right? The top part of your coffee cup, and then the first piece that you cut off. And there you go, you have your lid. Now, the last thing that you want to do to finish your lid is you want to make a hole on the top for the thermometer. So you're just going to grab your scissors and just make a small hole like that. Alright guys, so once you put the hole on top of your calorimeter lid, you should be able to put it onto your calorimeter. If it doesn't fit, you can cut off a little bit more of the cup. Just be careful not to make the lid too small. Alright. So now that we made our calorimeter, the first thing you want to do with it is you want to get it and you want to take it to a scale. And what we're going to do is we are going to record the mass of our calorimeter. Okay, so we're going to put that on. And you want to record the mass of your calorimeter, because this is going to allow us to find the mass of the water inside the calorimeter. Okay, we can calculate the mass of the water in the calorimeter by finding the mass of the calorimeter, which we just did, and then we can pour the water that we need for our calorimetry lab, and then we can find the mass of the water and the calorimeter. Okay, and finding the difference by subtracting this mass with the mass of just the calorimeter, we can find the mass of the water that's currently inside of the calorimeter. Alright, so let's talk about how to find the initial temperature of the water in your calorimeter. So what you're going to do is you're going to get a thermometer from your instructor and you're just going to put it in there and maybe leave it in there for about a minute or so. And then after you do, you can record the temperature of the water by just pulling out the thermometer and recording what the number is. Okay, so you want to let it sit there for a bit so you can get the temperature of the water accurately. But that's how you find the initial temperature of the water. Alright, so now let's talk about where you're going to get the metals for this lab. So you're going to be given one of these metals at a time from your instructor. And once you finish your calorimeter, you're going to return it to your instructor, and then your instructor will give you another one. Now, it's on you to keep track of which metals you've done the experiment with and which ones you haven't. So once you get your metal, you're going to go to your data table, and you're going to record a quick description of each metal. So as you can tell, they're all a little bit different. And so in order for you to keep track of which ones you've worked with, you're just going to write a description of the one that you're working with, and then you're going to record the data for each metal. Alright, so now let's talk about the two important rules for moving metals around during the lab. First, we talked about this earlier, but make sure that you use tongs and that you only grab the metals using the top bump of the metal. Because if you grab it like this from the middle, it's very unstable. Okay, and so what you want to do is you want to make sure that you move it around by grabbing this top bump. Because if we do that, it's a lot more stable, a lot more secure, and so you just want to be careful while you're moving it. The second thing is that when you put it into the boiling water, we're putting it into glassware, right? And so you want to be very, very careful when you place it down. You do not want to drop the metal into hot glass because the glass will crack. And if you crack any of the glass in this lab, you will get a 0. So just make sure that you're very careful. If you use the tongs and you grab the small bump on the top, it should be very, very controlled. And so just make sure that you very slowly put it into the glass. Heated glass is extremely fragile. And again, if you break something, you will get a 0 on this lab. Alright, so after you put your metal inside the hot water, you're going to leave it in there for about a minute or two. And that way, the metal is going to get to the boiling temperature of water. Now, if you guys look at this, it looks like I'm running a little low on water, right? The water level is getting a bit low. And so if you want to refill your water, you're going to go to your instructor and ask for a beaker of water. And then once you get that beaker of water, you're going to very slowly pour it into your boiling water. Now, you want to be very careful that the water does not touch the hot glassware because that can crack the glass as well. And what you want to keep in mind is that if you look, it's not boiling as much as before, right? The reason why is because if you add regular water to boiling water, the temperature comes down. So if you add water from the beaker to refill your boiling water, make sure you don't add too much. Make sure you add slowly, because if you add too much, it's going to take a long time for your water to heat up again. Alright, so after you've left your metal in there for about a minute or two to get it to the boiling temperature of water, what you're going to do is you're going to transfer it to your calorimeter. So you're going to do it the same way as before. You're going to grab the top bump with your tongs. You're going to take out the metal, and you're going to put it into your calorimeter. Now, the hot metal is going to transfer energy to the water, so you want to close the lid of your calorimeter quickly, and then you're going to put a thermometer in there. Okay, and this is how you're going to determine the final temperature of both the water and the metal in there. Now, you want to make sure that the thermometer is inside of the water, so you make sure you just double check that. If it just kind of falls all the way to the bottom, you're good to go. And you want to keep the thermometer in there until the temperature of the water stops changing. So you're going to want to take it out every now and then and check the temperature and see how much it changed, and you want to check until it stops changing, and that's going to allow you to find the final temperature of the water to put into your chart. Now, if you guys take a look at your data table, we only have 5 metals that you are working with, but there are more than 5 rows on your data table. The reason why I did that for you guys is because there could be a lot of errors when you're doing these calorimetry experiments. If you don't heat up the metal enough, if you don't get the right final temperature at the very end, it could mess up your data. For this lab, you will be graded on accuracy, whether or not you can determine which metals each one is. And so in order to improve accuracy, doing this multiple times is going to be helpful. So even if you're doing calorimetry multiple times for the same metal, it'll actually help improve your numbers. The way that you're going to do that is every time that you find the C of the metal, okay, if you do it multiple times, just find the average of that metal. So let's say, for example, you found the C of this metal 3 times. Okay, let's say you have 3 numbers. If you find the average of those 3 numbers, that's actually going to give you a better number or a better data set for finding the specific heat and the identity of this metal. So just keep that in mind. It's very helpful to perform calorimetry for each metal multiple times as time permits. And so just make sure that if you have the time, that you do multiple trials to improve your data for this lab. All right, so let's say that you're all done with your calorimetry. You found the final temperature of the water and the metal in there, and you want to do another trial, or you want to do calorimetry for a different metal. Well, what you're going to do is you're going to take the lid off. Then you're going to grab your tongs, and you're going to remove the metal by grabbing the small bump on the top. Now, you're going to either set it to the side if you want to do another trial with that metal, or you can return it to your instructor and get a new piece of metal if you want to find the specific heat of a different one. But before we do that, we need to find the mass of the water one more time for a different trial, because as you can see, some water comes out right as we do these calorimetry trials. So what you're going to do is you're going to put your calorimeter back on the scale, okay, and that's going to give you a different number for the mass of the calorimeter and the water. And so what you're going to do is you're going to subtract the mass of your calorimeter that you found at the beginning of the lab, and that's going to be your new mass of water for the second trial. Okay, so make sure you guys reweigh the calorimeter and the water after each trial, because that's going to give you a more accurate number for what the mass of your water is. And if you are ever running low on water in your calorimeter, you can always just refill it with water from the sink.